Let's simplify a bunch of problems here. First one is this. Remember, when you're doing simplification, you always have to use the correct order of operations. So PEMDAS. And remember, M and D are the same. So left or right, whichever one comes first. A and S. Now in this case, I need to recognize that I'm dividing. So I'm first do what's inside here. And you could do that first, or you could multiply by the reciprocal. That's what I'm going to choose to do. So I'm going to rewrite it like this. I'm going to write equals 1/6 minus 1/5 times 10/7. And then I distribute the 10/7 in, and I get 1/6 times 10/7 minus 1/5 times 10/7, and then I will be able to cancel common factors right there. I can cancel a 2 out, and I'm left with a 5 and a 3 here. And if I cancel a 5 out, I'm left with a 2 and a 1 there. So I have 5 over 21 minus 2 over 7. To me, a lot easier to do it that way. And then I realize that to get common denominators, all I need is to multiply this by 3 over 3, which gives me 6 over 21. 5 over 21 minus 6 over 21 equals negative 1 over 21. Of course, you could have done that in a different way. You could have multiplied this by 5 over 5, this by 6 over 6 first, got 5 over 30 minus 6 over 30, and then multiply that by 10 over 7. That's just as good. That's negative 1 30th times 10 over 7. The 3 and the 30 and the 10 cancel. You get 3 on the bottom. It's negative 1 over 21. Either way is fine. You could do it either way. All right, let's try another one. Again, here we're going to do correct order of operations. First, I'm going to add the denominators there. Again, I could teach you a little shortcut trick. Why don't I do a shortcut trick? And this is called clearing fractions. I always clear fractions. Anytime I can, I clear fractions. And the way you clear fractions is multiply everything by the least common denominator, which is 3 times 5, which is 15. When I multiply this by 15, I get 60. When I multiply this by 15, the 15 and the 3 cancel, and I get 5. When I multiply this by 15, the 15 and the 5 cancel, and I get 3. 3 times 3 is 9. See how much easier that problem is now? It's just 60 over 14, and now I can cancel a 2 out, and that gives me 30 over 7, and I think, is there anything else I can cancel out? And the answer is no. Done. You could have also done this problem another way. You could have just turned the 1/3 into 5/15, turned the 3/5 into 9/15, and now you see how you got that 15 there. Add them together and multiply the top, and you'll get the same answer. Another problem. A little different kind of simplification problem. This is a negative power. You remember what a negative powers do? If you have b to a negative power, it equals 1 over that same b to a positive power. That's the little formula that you have to remember. So I'm going to rewrite this problem at the very first step as 1 over 9. And the same thing here. That becomes 1 over 6 plus 2. And let's employ that little trick I just showed you. How am I going to, what's the least common denominator here? It's not 9 times 6, it's 9 times 2, which is 18. If I multiply the top and bottom by 18, and don't forget to distribute it, I will get, let me erase this and make some room. I multiply those by 18, I'll get 5 times 18, well 5 times 20 is 100, so 5 times 18 is 90, minus the 18 and the 9 cancel and you'll get 2, all over 18 times 1/6, the 18 and the 6 cancel, and you get 3. Well, remember that only cancels for this one. Shouldn't have canceled it there because you still have to multiply the 18 by the 2. When that 18 multiplies by that 6, those cancel, you get 3. 18 times 2 is 36. And there I've got a much simpler problem to deal with. 90 minus 2 is 88. 36 plus 3 is 39. Now try to get common denominators. See if there's any, not common denominators, common factors. 88 is 8 times 11, which is 2 times 2 times 2 times 11. 39 is 3 times 13. So is there anything I can cancel between these? No, there's not. So my answer is just 88 over 39. And if they want it as a mixed number, you can do that as well. How many times is 39 going to 88, which is 2, and what's left over to a 10 left over? 10 39ths. Does that look right? 40, 80, 2 short of 8. Yeah, I think that's right. All right, let's try this one. Now, if they're asking you for this to simplify this in the real numbers, the answer is no solution, because you can't take the 1/2 power is like the square root, and you can't take the square root of a negative number. But if they're asking you in the complex number system, if you've already learned about imaginary numbers, then the answer here is just going to be 8i, because the square root of -1 is the imaginary unit I. So depending on how they phrase the question, your answer is either no solution or 8i, one of those two. Let's try this one. Remember this? I just showed you a second ago. B to the negative m equals 1 over b to the positive m. So this equals 1 over 9 to the positive 3/2. Now, 9 to the 3/2 is equal to, I'm going to split 3/2 up into 1/2 and 3. Because I can take the 1/2 power of 9. What's the 1/2 power of 9? In other words, what's the square root of 9? 3, and so that's just 3 cubed. And what's 3 cubed? 3 times 3 is 9, times 3 is 27. There's your answer. One last problem, I think, or are there two? Nope, there's 2 more problems. More simplifying. Order of operations here, PEMDAS, so I'm going to first do this, then and this and this. So let's take care of all those things and leave everything else the same. -5 plus 6 minus -42 over -6 plus 2. So I just did all of the multiplication, left to right. I did all of the multiplication stuff that I could see. Now, someone might say, well, now you have to do division. Don't you? I don't see any parentheses. Well, there really are parentheses, because that is together on the top, that's on the bottom, that's on the top, and that's on the bottom. So the next thing to do is to simplify all of that, each top and bottom part. So that's -9 over 1 minus -42 over -4. Now simplify. Those become positive. 42 and 4 both have a factor of 2, so let's get rid of that. That becomes 21, that becomes 2. Now I multiply to get common denominators. I multiply this by 2 over 2. So I get -18 over 2 minus 21 over 2, which is, they're both negative, -39 over 2, which doesn't reduce. And finally, yep, this is the last one. Good old-fashioned order of operations. First do the exponent. What's 8 cubed? Or, sorry, 2 cubed. 2 cubed is 8. So I like to just rewrite the entire problem. Whoops, I didn't do this one either. What should I do here? What's -6 cubed? -36. Now that's where most people make the mistake. This negative right here is not being squared. I said cubed, I meant squared. That negative is not being squared. Only the 6 is the base of that exponent. If you don't believe me, punch it into your calculator. This is different than this. Those are 2 different things. This is positive 36, this is negative 36. So that's the mistake most people make. Now, from left to right, multiply and divide. What's 24 divided by 8? 3. Times 3 minus 5. See how I had to do that first? -36 minus, that became 3, and now I have to do this right here, which, notice that's a -3 times 3, which is -9. Just do one step at a time. Binary. Operations are binary, so do one of them at a time. Now go left to right, adding and subtracting. What's -36 minus 9? Negative 45 minus 5 is negative 50.